Well, got some parallel lines, two variables. Is there a way to solve this one variable at a time? Yeah. How?
Sine the x is equal to 180. And then once you figure out what x is, you can plug it in for 4.
Okay. I would copy the 3x here, because what kind of angles are those two? Those are corresponding, good, and so we can just copy the 3x. Then we have a what that tells us this is okay. What are those two angles called? 9x plus 12 and 3x. That's a linear pair, right? So they make a straight line. Anyway. Subtract your 12, add your 9x plus 3x, so you'll get 12x equals 168. And isn't that 14? Is that 14? Yeah. Alright, and then for y, how are we going to involve x to get y? Well, what's the easiest way?
You plug x in for 3x, or you could do 9x plus 9, but 3x because both of the angles together equal 180.
Okay. So here, he's talking about, I think, right? Yeah, so 4y minus 10. So we could do two things. Could do this version. So 4y minus 10 plus 3 times our x value now. And those are another linear pair. Or these two are congruent because they are what? Yeah, those are alternate exterior angles, so you could set those two equal and solve for y. So either one. This looks like 126. 9 times 14. And then 4, once we combine all those like terms, we'll get 146. Sorry, 168. 148. And then divide by 4. Which is what? Okay. Same thing over here. If we did this one, 3 times 14 is 42. And then 42 minus 10 is 32. So we would get 4y. We would subtract 32 from 180. It should be 148, not 38. Anyway, either way. How'd that go? Good review of some parallel line stuff. Just thinking we have, what do we have, like 5 weeks till the final or so? So we have the next 2 weeks, and then I think it's 3 weeks after. Well, we're done 3 weeks after Thanksgiving. So it's like 4 weeks, sort of.
So it's over everything we've done.
Yeah.
Could we just do like all our note packets?
Oh, no, you'll still get a note card. Get a note card. You know, I'm thinking maybe.
Plus all the pages we got to use in the past.
You never got to use oh, you mean like the.
Single, like the yellow page.
Yeah, the congruent triangles page. No, just the note card. But I was going to say, let's maybe try to remember to get that handed out at the beginning of December after break so you can start filling it out.
Or we just take the test.
Maybe a week or two before the final. The final, I guess they decided while I was gone on Monday that it will be 1 1/4 weighted as 1 1/4 tests. So like for us, a test is 50 points. That will be 62.5 points. 125% of the test. Does that make sense?
Yeah.
You're like confused.
No, that's just a lot. It's like just a lot more of our tests. So instead of 50% that our tests are now, it's going to be 62%?
Oh, no. So, like, oh my goodness, there we go. So right now the first unit was weird because we actually combined 2 chapters. That's along the way people decided to do that. So instead of giving you some gigantic test over all that stuff, I did it as 2 bigger quizzes. So that one was different. But normally in the grade book, quizzes are 25 points, tests are 50 points, or double a quiz, okay? The final will be 62.5 points, which is a fourth bigger than 50. Like a fourth of 50 is 12.5, so if you add down, so it's 25% heavier, if you want to say it that way, than a regular test. Yeah, I guess they decided that on Monday.
Can you look at her?
Yep, we're gonna do that now.
Did you get my email?
So these first 4, we didn't do all of 13, but we got the whole picture drawn, right? So remember that each one of the 4 has the same picture. You just have to change the labels each time. So redraw and relabel. All right, so give you a little bit of time to finish that. Remember, your picture might look different. As long as you labeled in order around, you're going to be okay. So it tells us that AD is x over 2, BC is 2x minus 12. It does say given parallelogram. So as soon as you read parallelogram, you know all 5 properties are true. Okay? Which means these opposite sides are congruent. And we can set those 2 sides equal. How do we get rid of the 2? Yeah, let's just multiply this whole thing by 2, which looks like this. That 2 cancels the first 2 under x, and we just get x. Over here, we have to distribute on both, so I should have had 2 of those. So it's 4x minus 24. Okay? Then we want to get our x's together, so if I subtract 4x, we'll have negative 3x. And then what does this give? Once you divide.
8.
It gives 8. It asks what is BC. I would do here because they're congruent, right? So this just says 8 divided by 2 instead of having to plug it in and subtract. Since they're congruent, you might as well just do the easier version, 8 over 2. So BC is 4. It would be 2 here, like 2 times 8 is 16 minus 12 is 4, but that's just a little bit more work. Okay? I sure did give you a lot of room on this, didn't I? All right. Okay, same picture. Or I should say you can use the same picture, but now we have an angle problem. This was side lengths, because it was talking about AD. This is now angles. So it says that angle ABC, which is this one, is 2 times BCD, which is that one. Yesterday we talked about if this is 2 times something that I don't know, what should I stick in there?
X.
Yeah, so that's 2x, which makes BCD just 1x. And what has to be true about those 2 angles? They are supplementary, good. They add to 180, so 2x plus x equals 180, or x is 60. It says what's the measure of ADC, which is down here. What is it congruent to? Angle B. Yeah, it's opposite angles are congruent. So that's just 120 because it's 2 times 60. Okay? Alright, so that one we use both angle properties. First we use the consecutive angles are supplementary, and then we use opposite angles are congruent. Alright, next one, again, same picture. I shouldn't cover that up. Okay, is this in angles or sides? situation? It is angle, so B is x minus 40, D 3x over 4. And what is true about those two angles? Good, they are opposites, so they're congruent. So x minus 40 equals 3x over 4. We have that same situation as we did right here, where we have a denominator. So we need to multiply by what? Yep. Okay, so we'll distribute. We'll get 4x minus 160. And then, is this 12x on the other side? Did I do 4 times 3x? No. It's 4 divided by 4, which is 1. So it's just 3x. Okay? Now, here's how I would do this step. I would subtract 3x to get x, and I would add 160 to both sides, and then in one line you get done. So x is just 160. Alright, it asks for angle B. 160 minus 40 is 120. Okay? Don't forget to go plug it back in. How you doing on this so far? Okay? Side lengths or angles on this one? Angles again. So 4x plus 11, 6x minus 1, and we're looking for C. Eventually we are. What can we do with those two? Yeah, those are supplementary. 6x minus 1 plus 4x plus 11. This is 10x and 10. And x equals 17. So subtract 10, divide by 10, x is 17. Angle C is congruent to which angle? It's congruent to A. 4 times 17 is 68, plus 11 is 79 degrees. Alright, parallelograms. What do you think so far? Those are pretty typical. I mean, you might have to draw your own picture, but also I'll definitely give you pictures. The rest of the worksheet, both front and back, is pretty similar to those, with the exception of these three. Okay? And the only reason they are different is because there are two variables instead of one. So it's actually not a geometry difference at all. It's purely just an algebra. These are written to be algebra review problems. Okay? So if you're understanding the properties, they still apply here. Nothing is different. Just we stuck an extra y in there so you have some practice with systems. So, first thing, before we do those, you heard me talking about it over here, but probably the better way to do these is by elimination. Why don't you grab some notebook paper or something? Elimination is in contrast to substitution. Those are the two main methods. And I think elimination is just much cleaner and more efficient. So I'm going to push you to do that. If you want to do substitution, that's fine. There are cases when it's better. But here's what we're looking at. So go ahead and write something down with me. And I'm just making this up, so I can't guarantee that numbers will be beautiful. But that's okay. Okay. The whole idea behind elimination, well, let me back up actually. Don't do this on your paper, I just want you to focus on that. Why can't we just solve that one equation? Yeah, and there's no way to solve two things with one thing. That doesn't work. So we always have to have the same number of equations as we do variables. And if you ever go further down the road in math, you might solve 5 or 6 variables with 5 or 6 equations. And of course with that, you wouldn't want to do it by hand. It would be a long problem. But algebraic systems can do that, like on your calculator, your TI-84 calculator. Match the number of variables with the equations. So now, our goal is to get rid of one of them. That's also the goal of substitution, it's just in a different way. So I either need to get rid of x, so I can just solve for y, or vice versa. Either one, it doesn't actually matter which one you start with, so do which one seems easiest. In this case, which one, in elimination I mean, which one you pick depends on how easy it is to scale up the coefficients. So what's a coefficient? That word in math comes up fairly often. And honestly, it's a word that, to me, has nothing to do with what it is. So it's the number out front of the variable. That's called a coefficient. Okay? We need to make one of these sets of coefficients match. We could either make the 3 and the 9 match or the 4 and the 6. So you tell me, in this case, which one is easier to do that. Is it easier to match these first two, 3 and 9, or 4 and 6? 4 and negative 6. It's easier to do 3 and 9. Okay, so when I say match, we're not doing anything tricky, we're just multiplying. Okay? So if I multiply this one, what do I have to multiply it by to make this 3 be a 9? By a 3, okay? So if we multiply that by negative 3, if you always multiply by a negative, then you're always going to add in the next step, which saves you a little bit of thinking, okay? So if I multiply this by negative 3, I'm going to write that new equation down here, and what is it going to look like? Negative 3 times 3x is what? Negative 9x. Negative 3 times 4y. Negative 12y. Negative 3 times 20. Negative 60. Okay? Everybody good with where those numbers came from? Well, it's because I know that to make this 3 be a 9, some kind of a 9, I have to multiply by 3.
Why'd you make the negative?
Well, you don't have to, but if you choose to multiply by a negative, then this next step will always be addition. So you don't have to think about it.
Or how do you know to multiply by a negative?
Always, just always multiply by a negative. Always multiply by, if you're going to change an equation, if you always multiply by a negative, you will always add here. That'll be nice. Okay. To get rid of these, this is the elimination part, by the way. This equation is now used up, so to speak. Like, we don't need to continue looking at it. Okay? So we're just going to focus on these two. And to get rid of those x's, we're going to add. So I always tell students to make that really big so that you see what you're doing. And we're just going to add vertically like you did back in elementary school. Do you remember doing like 10 plus 15? It's that. It's that same thing again. So what is 9 plus negative 9? It's 0. Do we need to write 0? You can. I don't, because I think it makes it messy. But those are done. We did that on purpose, right? We forced it to be that way. Okay, what is negative 6 plus negative 12? What was it? Negative 18, good. 10 plus negative 60. Negative 50. And now look, just by doing that one step, x is gone, and we have this dinky little equation that we've solved like 50,000 times, right? So how do you get y by itself? Yeah. And of course, you know, I told you I made up the number, so it's not going to be pretty. But go ahead and tell me a decimal. Should be close to 3, like 2.7.
Yeah.
All right, so we have one variable, but we have 2 to solve for. So how do we solve for x now that we know y?
It's just by itself.
What is?
What do I? The x. Which is 0 now.
X is not 0. So here, when we got rid of x, it's not because it was 0, it's because we took them all away. That's different, right? Like, think if I had 5 boxes sitting up here and you don't know what's in them. There could be nothing. That's when x is 0. Or if I just do this and swipe them off, there's no more boxes, right? So we don't really care what's in there at that point. That's what we did here. But now we have to go back and figure out what's in those boxes. So, if you heard Dahlia, she said we need to take this y value and plug it in here, here, or here. One of those, not all 3, just pick one. Usually you want to pick one that looks the nicest to you. Okay? If you do go back to this first one that we messed with, ignore all the purple stuff and just plug it back into the original. That's why I don't usually scribble it off, but for this I just wanted to make sure we didn't look at it. So which one do you guys think looks the nicest? Okay, sure. So plug this into equation 1. So we get 3x plus 4 times this guy, 2.7 equals 20. And then we just solve for x from there. So it's kind of double solving, right? I keep doing it, sorry. Well, what is 4 times 2.7? What is that, 8, 10.8, I think? Right?
Is that like there's plus?
Which
Yeah.
10.8.
Then we have to subtract it off. Like this part is just, excuse me, just normal solving. Let me change that back to purple. So 20 minus 10.8 is 9.2. Divide by 3. And we're going to get like 30. 0.666. Alright, how's that? That is solving by elimination. Okay? You might have to, well, let me let everybody catch up because I want to say. Use geometry to help set up 2 equations for that. So, number 1, what shape is it? Parallelogram. Number 2, is this angles or side length? Angles. What property are we going to use? Or what property is best to use? Is probably the best way to say that. 2 is that's parallel or congruent sides. 3 is bisectors. I mean, sorry. Yes, 4. It's better to do it this way to get those equations than doing 180. That makes this a mess, okay? So I'm going to write this down so you can try solving it tonight. Oh, and another thing, your paper makes these look like those are division signs, but they are not. They're plus, okay? Okay, there's our 2 equations. I want you to try solving for both x and y. tonight. Okay?
For just that one.
Just that one, yeah. Using the elimination, so try to match either the 3 and 4 or the 2 to the 4 would be nice, right? Alright.